So actually, if we apply this to every possible permutation, we apply this algorithm, we end up with 13 distinct patterns of length 3 that can be juggled with 3 balls. Right? This is an exhaustive list. Now notice here I've put a little star next to this guy because our algorithm still generates 3, 3, 3, but we don't actually, that's not a pattern in our notation. All right, remember we just, like this pattern should actually be represented simply by the number 3, right? Not 3, 3, 3. Okay. So anyway, there's a way of generating some patterns. Okay. Now, I guess as a juggler, because I always like to learn new patterns. And in fact, that juggling the baby one that I showed you, this one, I've only recently learnt that pattern, okay? I only recently learnt that one. But you know, a lot of the time I learn new patterns, I come up with new patterns simply by trying to generate them just using this procedure, right? Because now I have a well-established mathematical procedure for producing these new juggling patterns. Okay, so one thing we could do is try and work out a new pattern. So, I don't know, let's see how we go. Perhaps we can... Has anyone got any suggestions? If we call out a string of numbers.
How about 5, 2, 3, 1, 6?
5, 2, 3, 1, 6. Okay. Well, firstly, is that a juggleable pattern? Can you work that out? Are we able to juggle this pattern? So usually what I do, the first thing I do is to check the average, right? So we've got 7 and 3 is 10 and 1 is 11 and 6 is 17. So sorry, Peter, that's not going to work. But, well, what can we do? We could actually use the permutation test, right? To see where does it go wrong. All right, so using the permutation test, right, I'll just add the string, so take the string 0, 1, 2, 3, 4, add each of these digits to the digits in my original string. So here we've got 3, 5, 4, and this guy's 10. And now I need to take it mod, well, it's a string of length 5. Okay, so I need to take it mod 5. So what's that going to be equal to? Well, there's a 0 there. That's a 3. That's also a 0, right? Because it's a multiple of 5. 4, and that's also a 0. So it actually goes wrong in 2 places, right? But what I need to do is to somehow turn that into a 1. And if I can turn that into a 2, then I'd have 0, 1, 2, 3, 4, and that would be perfect. But in order for me to turn that into a 1, what do I need to do? Maybe add 1 up here. So add 1 to the number 3 here. In order to turn that into a 2, what do I need to do? Add 2. Okay, so if I apply that procedure, so we'll end up with what? 5, 2, 3 plus 1 is 4, and 6 plus 2 is 8. But I could write here, I could write 8, or I could write 8 minus 5 is 3, right? Doesn't matter. I mean, I could write 8, no problem at all. But because ultimately when I apply the permutation test, I end up taking it addition mod 5, so a difference of 5 is never going to matter. And in fact, by the same argument, I could have made that one 0. All right, I could have just left that as 0. But because Peter said 5 to start with there, no problem. What's the average of this one now that we've changed it? Well, 5 and 2 is 7, 11, 12, 15. What's the length? Is 5. Okay, so that's telling me I need 3 juggling balls to juggle that pattern. Right? And the permutation test says that actually the distance rule must also be satisfied, so we're going to have no problems with that. So let's go to Joe, and there it is, 52413. Certainly something that I wouldn't be able to do. But does everyone understand? Does everyone follow that at least? See how that works? Okay, and well, of course, if I was a good juggler, then I'd be able to just do this for any patterns and just start juggling, you know. Okay, so turns out this notation works for any number of balls, right? Because remember, we saw the number of objects that we juggle is just the average of that string. Okay, so I've made a few suggestions here. We could get Joe to try this 3-ball pattern. How do we know it's a 3-ball pattern? 5 and 3 is 8, and 3 is 11, 16, 18. It's of length 6, so 18 divided by 6 is 3. So we know that. We could also try some 7 and 9-ball patterns, which are, well, almost impossible for people to juggle. So this is just the pattern 9. Okay, so since it's a string of length 1, the average is 9, so that means it's a 9-ball pattern, right? Fairly straightforward. Well, not so for me. I can't juggle 9 balls, but Joe can. All right, and that's what it looks like. Okay, so we can do this for any number of juggling balls. What else can we find out about this notation? Well, one interesting thing is these so-called transitions, right? So one thing, when you see a juggler maybe performing on the street, they don't just sit there and juggle this one pattern over and over. Okay, they don't just sit there and juggle that. It's a little bit boring. Okay, if I was just to stand here for 10 minutes doing that over and over, ちょっとつまらないですね. Okay, so what might be interesting is if I change the patterns a little bit, right? So if I start by juggling this pattern and then change it to this one and then change it to this one, right? And then so just make these changes every so often like this to make it look interesting, okay? But I need to know, well, can I change from one pattern to the other? Is this possible? And this is what I mean by a transition. Changing between patterns can be difficult. For example, this is the pattern 3, and say I want to change to a 5-1 pattern. So here's 3, all right? Here's 5-1. But how do I change between the two? I know it's possible because I can do it. I just did it before. So here's the 3, right? Here's the 5-1. But how do I do it? How can I work out how to do it, more importantly? Right? One thing in particular, see if I have a 5-1, 5-1, and then I just change straight to a 3, what's going to go wrong? Right? The distance rule. Remember, take these two entries, the 5 and a 3. Their distance is 2, right? Their difference is also 2. So by the distance rule, that transition, so whatever's going on in that circle there, that's not going to work. Okay? So, I've got it here going the other way. Try the cascade 3 to the shower 5-1. So we must use other patterns in order to go through that transition.